Hey, fancy meeting you here.
I just want to know, are you laughing because literally the last 60 seconds leading up to this, you just see me constantly scrambling, trying to get everything set up?
Basically, I think did you brush your teeth in the last 60 seconds?
No, I was just, I just ate lunch. I had my toothpick, tried to get, it was a whole thing. So I think everybody
Yeah.
wants to know that. So,
Sorry for letting everyone know that, but it's funny to watch Adam primp, right before the show.
yeah, it's, I got to look my best. Got to look my
Uh-huh,
best.
yeah,
Yeah,
check
you
the
got to give off
eyebrows.
that. Yeah, give off that air of effortless perfection, right?
That's the goal, except it just shows, all I do is show the effortless part, but everything else doesn't really shine through there. So,
Hilarious.
welcome back to day 3 of our Copilot themed Spooktacular week. We have had quite a bit of fun these past couple of days, and today is actually the last day of our Copilot themed week, or themed days, where just a little recap as we say hello to everyone as they stroll in to the chat. So we had an idea. We had an idea that we were going to build an app. We were going to build an app that was going to scrape Twitter for emojis, anything that was tagged hashtag AWS Copilot. And yeah, we technically we don't scrape. It's just use the word. But so we had this idea. So we decided we're going to build this app, and we did it in a very short amount of time. We broke up into teams. We each kind of owned a service, and it started on Monday with creating a scheduled job that runs every minute, scrapes Twitter or calls Twitter's API and looks for anything that has the hashtag AWS Copilot, and it takes all the emojis in that tweet, and we tally them. We store them in actually, the schedule job doesn't do that. The schedule job just collects that data. Then on day 2, on Tuesday, we had an API service, right? So we deployed the API service with Copilot, service discovery, all the plumbing underneath was automatically connected via Copilot. And yesterday we started to ship that data from our Twitter API scheduled job into that API service. And so we started to fill that database with tweets. And today, to put the bow on it and wrap it up, we're going to deploy a front end service that's going to call that back end API service to get all that data and present a really nice front end with all the popular tweets. So with that,
we're going to count the votes.
We're counting the votes. So if you're watching right now, you're going to want to, if you have Twitter, just hashtag AWS Copilot, all one word, and put your favorite emojis there. And you have how many? 240 characters, right? So go nuts.
280.
Use them all. 280, whatever it is, use them all, because Brent did, FA did yesterday, and he liked the vampires, and then I one-upped him and did the robots, and no, Brent did the robots. I did something else. That was you. I'm gaslighting Brent. Sorry. But anyways, so yeah, it's been pretty fun. I mean, what do you guys have to say about it? I've just been doing all this talking.
I think it's been awesome, and it's something that let's talk about it in human terms for a second, because this is very much like what you would do if you were at a startup, or maybe you're at your company, but you wanna experiment and you wanna get something up and running quickly and easily. You huddle together as a small team, and you sit there and you divvy up the jobs. You guys, basically sprint planned it out. And at the end of the sprint, you need to be able to show, okay, this is what we came up with, and you were able to deploy it out to a cloud-based serverless platform and have this up and running super easily, right? And you can do it all using Copilot, and you didn't have to even really know how to build AWS infrastructure. So you didn't have to go talk to an operations team or someone at AWS and ask, like, how do I go build these things? And you didn't click around through the console and come up with something completely unreproducible. This is a really, really cool way to highlight what Copilot brings to the table and how it makes it so easy, because you're a developer in this case, and you're able to completely build infrastructure in a best practices sort of way and have it up and running and ready to go.
Yeah, and that's really that's the coolest thing about all of this. The only resource that we had to create before all this started or outside of Copilot was registering a domain with Route 53. And once we had that domain registered, all we did was Copilot app init -- domain. And so the tool found our domain, created our hosted zones, set up our ACM certificates to connect with HTTPS and do TLS termination of the load balancer. All of this stuff gets automated. And I'm certain that we'll talk about that later on as Adam goes through the deployment.
Exactly. And, the only thing, so, we got to give props to Uttara. She's she manages the team. She manages the team, right? The Copilot team?
Yeah, she's the DevX manager.
Perfect. So, she brought us together, came up with this amazing plan. Like, it's just, some people are just so good at their jobs, and she had this plan, and like, we just knew what to do. So we all got started. And the cool thing was the API service, I didn't have to know anything of what they were doing. I didn't have to know what code they were writing in. They just had the contract was, here's our endpoint. Here's what we expect to receive. So all I had to do was just make sure that my JSON payload that I was shipping that service matched what they needed. That was it. So and I mentioned this, I think yesterday, but I wrote my service in Python, and the other two services are written in Go. So just again, to further highlight that I didn't have to do anything crazy to get everything to talk to each other. That was all built in with Copilot. I just had to write my code and say, here's the API I want to send to, which is another service in our environment.
So
which
cool.
is pretty cool.
And you're able to do that over service discovery, which you didn't have to build. Austin mentioned, not having to build and maintain certificates. We're going to see that today when we bring up the load balancer. So there's just so much stuff that, you don't even have EC2 instances. So like there's so much happening with so little to actually manage and patch and maintain that it's awesome.
And so there was a question in the chat I'm going to bring up here. Hey there, Ben. So does Copilot support Docker Compose? So I'm gonna take a stab at this one, and then I'll let you two, correct me if I'm wrong. Well, so there is actually Docker ECS integration. So if you wanted to stick with Docker syntax and Docker manifest type files with Docker Compose, that's where you would look at using the Docker ECS integration, which it's just built into Docker. Is that GA yet, or is it still developer preview?
No, I think it's GA. I think it's built into the mainline Docker desktop now. Okay,
but so you can't directly deploy, via Copilot using a Docker Compose spec. However, you can still use Docker Compose for your local testing, right, to make sure that everything works as you expect. But it can't be used to deploy Copilot templates. Is that, Austin? Am I correct?
Yeah, that's right. Copilot uses a very similar, or not similar, but a very friendly sort of YAML manifest style that might be familiar to those of you who have used Docker Compose in the past, but it's not directly compatible. We do some things to make building your Docker images as easy as possible, and we actually had an external contributor add cut a pull request over the last week to add some additional Docker build directives to the Copilot manifest, but it's not directly one-to-one compatible with Docker Compose syntax.
Yeah, and that's not the goal either. We love Docker, we love Docker Compose. We think it's great, but at the same time, ultimately, what we're trying to do is connect the developer to being able to run their container or set of containers or application on the cloud in the best way possible, and trying to map that through the lens of Docker Compose isn't necessarily the most direct way. So we thought it would be better to build our own tool that can do that more directly. So that's what Copilot is doing for us.
And maybe let's go to the screen share. Let's look at the manifest and see what that looks like, just to give you an idea. Because as Austin said, the manifest file, it's not, it's very easy to read. It's human readable. You know, everything you read in a Copilot manifest file will make sense, and you'll understand its purpose, right? Whereas sometimes, not knocking any other service or anything, but sometimes, manifest YAMLs can get pretty crazy. So let's look at an example for a load balanced web service. You can see it's plain English here. So you have the name of your service, the type. So there are 3 types of services you can deploy with Copilot. There's a load balanced web service. This is your front end, web service that's behind an application load balancer. Then there's a back end service, which your front end most likely will talk to, right? Or just a back end service that's going to run and do whatever the needful is. And then the schedule job as well, which was just released. And Austin up here is the author of the schedule job. What do you call it? Schedule job
Feature,
I guess.
Feature. Thank you. My brain, it's not working. But anyway, so
it's not just me on all of this. It's the team that I work with is great. We do a lot of great work distribution, and I had a lot of help here. This is a big feature, and it's not just a one-person effort.
That's fair to say, and that's a good point.
Yeah.
Honestly, the Copilot team's amazing.
Totally. And also, it's worth pointing out that Copilot is open source and developed in the open. So even if you're not an AWSer, but this is something that's interesting to you, you can absolutely contribute by opening issues, opening pull requests, suggesting features that you'd like to see. All that is definitely something you should get involved in. It's still really early. We like to say at AWS it's day one. It's still basically day one with Copilot. So there's still a lot that is going to happen, and we want to know what's most important to you. So open some issues, at minimum, and then if you have the ability, open some pull requests, and we'll review those and work with you on getting those merged in.
So going back to our application, so this is our GitHub structure here. So we deployed our Twitter scraper service, we deployed our API service. So today we're going to deploy our front end. So here's what we'll deploy it. And what we'll do is, after we deploy it, I'm going to recommend people go out there and tweet hashtag AWS Copilot with the emojis, and let's watch as the actual everything, the front end changes the tallies in real time. So as I mentioned, the front end service is written in Go. You can see FA was the author there. And let's really quickly, while we're here, let's look at the Copilot directory. I just wanted to show this because we were talking about the manifest. So when you initialize your project in Copilot, it's going to create a Copilot directory with the manifest file. And this is where you would add any other features to your service. So if you wanted to have add-ons, right? We talked about add-ons yesterday. If you wanted to update your manifest file for the next deploy, you wanted to increase CPU or increase memory, add an environment variable. This is where you would do it in the manifest file here. But I'm going to stop talking about that. And what I want to do now is I want to first look at our applications, Copilot app show. And you can see right now we have a backend service running. We don't have jobs here yet, but I'm sure we will at some point. But if I do this, I go Copilot jobs ls. Oops, that's not what I wanted. Copilot job. And then we do ls. We can see here are our scheduled jobs. API test, this was just something we were testing, but the one that matters is the Twitter scraper job. So we have our two services up and running right now, and I'm able to, see what's going on in my application all from the command line. So actually, what if we did Copilot service, let's do Copilot service logs. And let's just see what the backend service is doing. Spitting out a lot of crazy stuff. I think these are emojis. So every time someone hits the front end, I believe this is the service is responding with the emoji, the emoji UUID, and then also the rank. I'm guessing. So, okay. But anyways, so we see our services running. Let's Copilot. Let's run an init inside our front end directory. We're going to start with defining our type of service, which is a load balanced web service. Now, I have a manifest here already. So what's going to happen is as we progress, it's going to recognize that I already have a manifest, and it's not going to recreate that for me. So we'll select that. Oh, what did we name the service? I forgot.
It's PU.
PU, that's the one. Thank you. And we talked about this yesterday. There's a reason why our services and environments have kind of weird names. It's all going to come together very soon. I promise. So all I did was to initialize my front end service. I defined the workload type. I named my service. I said, here's where my Docker file is. And Copilot now is going to ensure that we have the baseline resources to get started. This includes an ECR repository and any other, kind of boilerplate, components that are needed will be built here. So, and you can see here, it recognized that I have a manifest file, so there's no need to recreate one. So just give that a moment. Okay, perfect. So it's asking me if I want to deploy a test environment. I'm going to say no here. And what I'm going to do, because we have an environment that already exists, I'm going to Copilot service deploy and MPK.
Okay. But since there's only one environment, should automatically recognize it.
So let's just do that. Yep. There you go. So it automatically recognized the environment. And now, as we've done yesterday and the day before, it's building my Docker file. It's my Docker image. It's pushing that image into ECR, the Elastic Container Registry, and then it's going to deploy my service and connect it to the load balancer. And at the end, it's going to give me a nice URL, which we will then go to in the browser. But anything you guys want to add as we're kind of waiting for it to deploy?
It looked super easy.
It's too easy.
I'd like to know, okay, how long did you guys spend writing this set of apps? Like, just, we're talking about the deployment and the management of the infrastructure, and all that's super easy, but just let's, side conversation. How long did it take you?
I think we had our first meeting about this on Friday of last week. Friday morning, we had the brainstorming session where we figured out what we were going to do. From there, folks broke off into their little one-person or two-person teams to work out the front end, the back end, schedule job. And so obviously the schedule job was done by Monday. Adam was super fast getting that one out the door. Then Monday afternoon, I think, was spent connecting up the back end to the job to make sure that all the JavaScript or the JSON payloads were correct. And there was a little bit of work yesterday to make sure that the front end was talking to the API backend correctly. But all told, start to finish, I think this was about, I don't know, 16 hours of work for 3 people.
That's incredible. And,
4
I mean, I
people.
think that, back to that notion of experimenting, I think that really speaks highly of what the possibilities are, because you can go from brainstorming session to, something that's beyond MVP. It's MVP from a functionality perspective, but like with Copilot, we could have this deployed production worthy right now, and that's pretty incredible. With 16 hours of work put into it each, so that's
Yeah.
awesome.
All it would take is just updating an auto scaling setting in the manifest
Yep.
to let it accept really heavy traffic.
Yep, exactly. Which, depending on how many of our viewers hit the endpoint when we bring it up, maybe
So
we'll
FA
wish we
says,
had done.
FA wants to correct me on how long it took. It was even faster than I said. It was so little coding time even.
Yeah. Now, granted, I mean, FA and, everyone that was working on the other services, they were way quicker, but the point is, to FA's point, I didn't think about infrastructure once. I did not even have to think about what that meant. I just had to think about, is my code operating as I expect it to operate? So, okay, so we have our front end, it deployed. So do you folks see the URL now? Do you see it all come together?
I have to say, yesterday when you were talking about it, and like, we could only see some of the letters, I was embarrassed. I could not come up with what the word was going to be. So, but I fail at stuff like that. So
it was tricky. But so here you go. So here's our front end, our beautiful front end written by FA. And now is when I want to challenge you folks to go on Twitter and just tweet hashtag AWS Copilot, and then put as many emojis that you can fit in there that you love. And what we should see is this will slowly grow, and we'll start to see hopefully some new emojis, or we may see, the existing robot emoji take the lead even further. So we don't know, but that was it. So, let's talk through that. What just happened while it deployed? So yeah, it built my Docker image, it pushed it, but then it deployed this service. It connected. Obviously, this service has to run somewhere, so it's running in a cluster. It has a health check, which the health check for the service. So this is another thing to point out here. Oh, let's do this actually. Sorry, C9 open manifest. I don't have that there. The health check was actually defined. Oh, I thought it was. Am I crazy? It's defined in our other service. I lied.
Yeah, the backend services have a container health check that it's easy to define there, since they don't really talk to a load balancer. There are load balancer health checks you can play in your service code.
That's an important distinction, because with load balanced services, you do have the load balancer health checking, and you could add optionally an additional container health check if you wanted to, but it's not super critical. But without the load balancer, no opportunity to health check unless you build that into the Docker health check functionality. So I think that's definitely great to point out. It's also just good Docker practice to have that health check built in.
And yeah, absolutely. Like, it's, even if you're running it locally or wherever, it's good to just understand and write meaningful health checks too, by the way. We have this conversation a lot, Brent, but your health check shouldn't be checking the database and all the other services in the environment to make sure everything is working. It should be very specific to your code and that your code's functioning in a healthy manner. So I don't know if anyone else has tweeted, but Brent, Austin. Okay. All right. So, and then we have the numbers have changed. Did you see it?
Yeah.
So it looks like we're getting a lot more here. Hamburger. I like it.
Oh, hamburger. Where's my? Oh, mine still hasn't shown up. Wait, did I send the tweet?
You're.
I just added a bunch for cowboy hat smiley face. And wait, I forgot the hashtag. All right, that's actually
Retweet it
good.
with a hashtag. I
Yeah,
don't know.
good test of that functionality. You guys passed. Nice.
And, so we can go, if we're just curious, we can see the logs. Let's do this. Let's see the logs for our API service. FA loves burgers, very good. And let's do Copilot service logs. So another cool thing about Copilot is it recognizes there's multiple services. I didn't pass in a service name to the logs function. So it's asking me which service do I want to see logs for. So let's look at the backend logs. And I want to see. Let's go. Actually, let's look at the front end logs too. Let's see if I were to
Emojis and logs. Love it.
Isn't that awesome? And so what I'll do too is I will actually tweet as well. I want to just do it really quick here. Oh, I see. Yep, I see Austin's. I see Brent's there. Very good. And I don't know if anyone else is tweeting. Please keep them coming.
I don't know if we're seeing the screen you're looking at. We're seeing GitHub.
Sorry. Yeah, I moved this aside. You just tweet really fast here. Let's go back to this. Oh, what did I do there? Oops, there we go. So you can see the numbers are shifting. So our service is running, it's live. And I mean, that's pretty much it. So we built a 3-tier application in an afternoon, a couple of afternoons. We deployed it. It's running in the cloud, and we're not managing. Oh, good question.
Yeah, let's address that real quick. Because again, let's talk about it from, you're a developer. How do you know what to choose when confronted with some of these choices?
Yeah, so so when we talk CPU and memory, I often when I look at this, I kind of look at memory and CPU as I'm defining my resources in the same way. So I'm not actually using 256 CPUs. I'm using just a fraction of a CPU. So basically, if I change this to 1024, that's going to give me one virtual CPU. Same with memory. If I was changing it to 1024, that'd be 1 gig of memory. So that's just how we carve off CPU. Because in the microservice world, in the containers world, oftentimes you don't need a whole CPU. And if you're really building, lean microservices, you just need fractions of a CPU, fractions of memory for your code to run as you expect. And ideally, if you need to scale, you should not be thinking about vertically scaling, but you should be scaling horizontally. So as you need, more compute or more memory, you scale out to serve that traffic and then scale it back in.
Yeah, so this is a thing. This is a mechanism that I don't know if Docker started it necessarily, but it's part of the Docker nomenclature. So when it comes to ECS and then when it comes to Copilot, we just carry it through straight to Docker as we're bringing up the image. But CPU 1024 is, like Adam said, it's the equivalent of one full CPU. So you can go 512 or 256 and get half or a quarter pretty easily. So, and I linked the docs for the Docker documentation that kind of explains that.
Perfect. And so we can see, people are hitting the server. And has anything changed? The vampires are coming up. FA's vampires.
Oh, I need more cowboy hats.
So please keep tweeting. Let's tweet your favorite emoji with the hashtag AWS Copilot. But yeah, so it's all coming in live, and just for funsies, I'm going to actually go into the console and I'm going to show you the ECS cluster and all these things that me as the developer didn't have to think about, but it's there, it exists. So let's look at it. So we have our back-end service and our front-end service. So these are services. These are long-running containers that we need to ensure that they're always running at our desired state. Okay, so what does that mean? That means that we've defined we always want one back-end and one front-end service running at all times. So the orchestrator is going to ensure that we always have, one service running one task running within each service. Obviously, auto scaling, those numbers can change, as well as I could have changed those numbers in the manifest file as well under count. And Austin, I think it was you who mentioned this on Monday, but I don't necessarily have to set count. And we talked about CPU earlier. I can set auto scaling here in my manifest file, and it's really easy. So let's look at what it would take for me to do that.
And this is basically the difference in going, from dev mode to production mode.
Bingo.
I mean, basically.
Yeah. And, so we talked about that case of I've allocated, fractional CPU, fractional memory. And if I know that if my app runs at a CPU percentage of, 90% or greater, then that means, for a certain period of time, then we need to scale out to support the demand. David thinks the tweets, did you say the tweets or the emojis are spooky?
He said the tweets, but
look by just going back here, you can see the numbers are changing. So Brent, your cowboy is coming up in the ranks, right, but the vampire is working.
I think the robot has evolved and is now tweeting on its own, keeping itself at the top.
This is what happens. So anyways, going back to our services. So we have our two services, and then we have our scheduled job. So our scheduled job is not going to show up as a service because it is not something that we want constantly running. We only want it to run on a cron-based schedule, right? A schedule that we've defined. So in the next minute, it's going to run, and we'll see it come up here. And then when it comes up, that's when it's going to go talk to Twitter. Are there any new tweets? And then send that data in. There's just, it was so easy today. Like now I'm just filling time here.
Yeah. Should we talk about DNS?
Yeah. Actually, yeah, that's one of the features was certificate, DNS, like how did all of that get put together? Because when I look at the front end, it's secured with TLS, which, yay, good job.
Yeah. Well, the Ghost did that, and that Ghost name is Copilot, of course. But this is what happens when you initialize a Copilot application with the domain flag. So that when you run Copilot app init, there's a flag you can pass in where when you're initializing the app, if you have a domain registered in Route 53 or transferred into Route 53 from another registrar, Copilot will be able to find that domain and create a bunch of extra very cool infrastructure on your behalf. So when you do app init, we create a couple of things. So first off, we create a hosted zone, which holds all of the records for DNS servers, which help obviously route traffic to the domain and all of its subdomains. And we use Amazon Certificates Manager, ACM, to generate a TLS certificate. So we have certs that we generate for, I think it's a wildcard on the environment and on the application subdomain. Obviously, you can see in our URL, we have pu.npk.in, and in order that goes service environment application. That's why we call our app IN and our environment NPK. So this is how Copilot will automatically generate URLs for your load balanced web services: is service name dot environment name dot app name dot domain. And so all that happened here was I specified a domain, then we deployed an environment, and we deployed a load balanced web service. And you can see that all of the target groups, all of the load balancing, all of the listeners sort of updated accordingly with this domain name. HTTPS is enabled by default without us even doing anything other than passing in the domain. And the service is exposed automatically on this URL. We go, app or frontend test.app.domain. And
Awesome.
that's just out of the box.
And
doing normal Copilot workflows.
That's so good. The certificate is free, provisioned from ACM, tied to your load balancer, automatically managed and renewed when the time is right. So, I don't know.
No more
about
outages.
I was about to say, like, I think everywhere I've worked, we've had some kind of outage from a certificate expiring, and all of a sudden, like, everything cascade fails, and you're like, what just happened? No one, who touched what?
It's always DNF.
Yep.
So actually, it looks like, so I wanted to watch the back end or the scraper job to see if anyone else was tweeting, and it looks like it captured some more tweets and sent them. Like, I see some names here. I don't.
Yeah.
Even if you don't
Ghosts are at the top.
even if you don't tweet yourself, retweet some of my tweets, and that way, we're getting some amplification. That would be amazing. So y'all get on that out there in Twitch land and YouTubeville.
Yes,
I see your motive here. You're trying to get more votes for the robot, Brent.
That's right. That's right. The robot or the cowboy smiley. Either way, right. I like them both.
Let's watch. So we watched the logs of the last job. Let's see now if it shows up. It did. Something went up and I missed it. I don't know which one. But yeah, so it looks like the ghosts are winning right now.
We gotta do something about that. No, don't. I'm not putting your comment on the screen, David.
Please retweet ghosts. Yes.
All right, fine.
But yeah, I mean, this is so. So you can see if anyone sees their name here, you're famous now. But yeah, you can see, and it's a lot of me. Clearly, I was doing some tweeting myself. So
that's awesome.
Yeah, I've been periodically sending out bat and snake emojis throughout this broadcast.
Fantastic. I guess the last thing I want to just say about this is, from a server and from a management perspective, every single component here is fully managed by AWS, down to our database. And so let's talk about that. I don't have to patch a server. So for my containers, it's Fargate, so it's serverless, but in serverless, there's always, servers. I get that, but I'm not worrying about those servers, right? And so if there's a patch, something happens, I just kill that task, let a new one come up, and now I'm patched. That server, yep. Right? I don't think about it. It's just I get the latest server. So our containers are running in a serverless way. Our database, Aurora, is serverless Aurora, so I don't have to do anything there.
That's right. And as EdgeGeek points out, cattle, not pets. Even the database is cattle at this point. Yes. So it will auto scale for us. It'll go up if we need it, because this thing takes off and suddenly we're blowing up on Hacker News or something. It'll scale for us, and then we have auto scaling at the container level, so we can automatically raise up whichever service needs to go up. If it's, if it's the Golang apps, then they're probably going to, handle whatever we throw at them. But if it's the Python, piece, then it's probably going to struggle and needs some help. So we might have to scale it out a little bit more. So that's one of the cool things about just microservices in general, is you scale just the pieces that need to be scaled. And the fact that it's on Fargate, you don't have to mess with any of the underlying infrastructure. And then the load balancer, as traffic comes into that scales and, goes up, expands as necessary, and then contracts when it's able to. So this is terrific.
Yeah. Yeah. And obviously, when you talk about the benefits of microservices and containers, if you were running a monolith in a container, just one of the struggles is considering how do you scale, right? Having to think about what is that metric to scale. And, I may be scaling, there's one function of my application that's overloaded, but the rest is underperforming. It's kind of silly to have to scale out everything, right? This just for one piece. So that's why you break it up, scale only what you need to scale.
Exactly.
So that was really fun. Oh, the robot is back in the lead.
Won. Somebody pushed the robot over the finish line.
Yes.
Let me zoom in here. I just realized I wasn't zoomed in. Sorry about that.
That's all right. Because look, and Cowboy Hat is number 2.
There you go. So
thanks, y'all.
It's the gold medal goes to the robot, silver to the cowboy, bronze to the ghost.
Final. The race is over.
It's over. I'm deleting everything.
All right. So thanks everyone for joining us. Little schedule update. We won't be on tomorrow. There's a conflict. So there'll be, I forget which other show. There'll be another show on tomorrow in our spot on Twitch. So join us coming up on Monday, and we will be back with more container chat. So until then, huge thanks to the Copilot team for putting this together, and to Adam for contributing the scraper code and running the show and all that. So this has been fantastic. All right. Until next week. See ya.